If your AI fails today, who actually takes the fall? It's a heavy question, right? But it's a daunting reality we absolutely have to face. As our organizations scale and adopt these incredibly complex AI ecosystems, well, they often act like unpredictable black boxes. Sure, they're powerful, super powerful, but left ungoverned, you're looking at massive risks. We're talking biased decision-making, data privacy breaches, or just flat-out catastrophic operational failures. So how do we actually get a grip on this?
Welcome to This Explainer. I am so thrilled to guide you through this material today because we're diving into ISO/ISC 42001-2023. Now, do me a favor and completely erase the idea that this is just another boring compliance checklist. It's really not. Instead, we're going to look at this standard as a robust, incredibly powerful blueprint. It's a way to transform opaque, risky AI into a transparent, governable, and highly secure asset for your organization.
Here is our roadmap for today. 1. Governing complex AI systems. 2. Leadership and ethics committees. 3. Documenting the AI lifecycle. 4. Taming the black box. And 5. AI incident response protocols. Let's jump right in.
Section 1. Governing complex AI systems. Building the foundation.
Think of this framework as a robust cage to tame the AI beast. ISO/IEC 42001-2023 operates as an Information Security Management System, or ISMS, but it's specifically adapted for artificial intelligence. The standard requires a highly systematic approach to managing information security risks, and these are tailored directly to the unique vulnerabilities of AI. Things like managing massive data sets and securing autonomous decision-making processes.
To secure that ecosystem, there are several core governance pillars you've got to have in place. You need proactive risk management to, catch threats before they happen. Then there's asset management, which is crucial for securely handling the vast amounts of data and IP your AI uses. You also absolutely need strict access control because, let's be real, not everyone should be able to tweak the algorithm. And finally, incident management and continuous improvement. These ensure your system learns and recovers from the inevitable hiccups, all while maintaining fairness and accountability.
Section 2. Leadership and ethics committees. Establishing accountability.
So here's a crucial takeaway. You must establish a dedicated ethics committee. Think of this committee as your human guardrail. They don't just sit around in a boardroom. They're actively overseeing algorithm development and reviewing AI decisions. They're the ones ensuring your models mitigate bias and actually comply with complex privacy laws like GDPR. Basically, they bridge the gap between technical output and structured organizational accountability.
And look, top management absolutely cannot outsource this accountability. They just can't. They must take an active, documented role in cultivating a responsible AI culture. If leadership isn't completely on board, if they aren't actively reviewing the work of that ethics committee, well, the entire governance structure just collapses.
Section 3. Documenting the AI lifecycle. Getting into the weeds.
Documenting applications systematically within these complex setups means you have to rigorously track this specific pipeline. First up, you secure the data during processing. Next, you actively prevent vulnerabilities during the algorithm tuning phase. And finally, you establish strict controls before and during model deployment. The key here? Every single step must be mapped out and fully auditable.
Let's zoom in on that first step. During the initial data processing phase, organizations must strictly apply data minimization and anonymization. This is absolutely vital. You should only collect the exact data you need to achieve your specific purpose, and you must anonymize it to protect personally identifiable information. Doing this directly aligns your AI practices with privacy regulations like GDPR right out of the gate.
Then we hit algorithm tuning. You've got to constantly be asking yourself, does your tuning process actively test for adversarial vulnerabilities and hidden biases? Like, are you actually feeding it diverse, representative data? Because if you skip rigorous testing here, you are literally baking flaws directly into the final deployed model. And trust me, that is a massive liability.
Section 4. Taming the black box. Shining a light on AI decisions.
To defeat the dreaded black box, we must use explainable AI, or XAI. It's no longer enough for an AI to just spit out an answer. The standard actually mandates that when a system makes a critical decision, a human being must be able to understand the underlying reasoning. That logic cannot be hidden behind an impenetrable wall of code.
Think about why this matters in the real world for a second. If your AI denies a customer a loan, or maybe it recommends a specific medical treatment for a patient, you can't just throw your hands up and say, well, the computer said so. The standard mandates that you must be able to explain exactly why that specific decision was made to the affected individual. Transparency is no longer optional, folks. It's required.
So how do we achieve this high level of transparency? ISO/IEC 4001 demands relentless documentation of your models and continuous auditing by your ethics committee. You have to document the data you used, the algorithms you chose, and the actual reasoning behind your design decisions. It's this continuous feedback loop that ensures your AI remains explainable, even as it evolves.
Section 5. AI Incident Response Protocols. When the algorithm fails.
We have to understand that an AI algorithmic failure is fundamentally different from a traditional IT failure. Look, if a server goes down, it's binary, right? It's off, you reboot it, it's back on. But an AI failure, like a sudden model drift causing an algorithm to start rejecting valid loans, that's probabilistic. It's way more complex to diagnose, and it requires a completely different type of response.
Consider this specific scenario. Imagine your AI-powered fraud detection system suddenly starts misidentifying legitimate customer transactions as fraudulent. You can't just unplug it. You need a highly specific response protocol to halt the system, investigate the algorithmic drift, communicate with those affected customers, and of course, correct the model immediately. Or think about high-stakes real-world environments, like autonomous vehicles. If an AI system encounters some unpredictable edge case out on the road, incident response means having immediate emergency overrides engineered right into the system to protect human life. The stakes literally couldn't be higher, which is exactly why your response protocols must be ironclad.
So your protocol has to include these crucial steps. First, develop specific response plans ahead of time. Second, use continuous system monitoring to catch that model drift early, long before it impacts your users. Third, implement swift corrective actions to halt the damage. And finally, conduct a deep root cause analysis so you can retrain the model and prevent that specific algorithmic failure from ever happening again.
I want to leave you with a final, provocative thought to take away from today's explainer. Take a hard look at your own systems. If lead auditors walked right into your organization tomorrow, could you truly explain, document, and defend every single decision your AI makes? By leveraging the blueprint of ISO/IEC 42001, you absolutely can. Thanks so much for learning with me today.